This lesson is on section 7.2, similar figures. The definition of similar figures is two or more figures that are congruent if one was dilated. Dilated simply means that it is shrunk or expanded. The symbol for similar figures is the top part of the congruent symbol. The top part means same shape. The equal sign meant the same size, so together that's how we got congruent. For similar, all we're talking about is that they are the same shape. They do not have to be the same size. Characteristics of similar figures are that corresponding angles are congruent. When we look at these two equilateral triangles are similar figures. Whether the triangle is small or big, the angles would remain 60 degrees each. The second characteristic is that the sides are proportional. If one of the pairs of sides, for example, this one might be 3 times the size of this one, then that would have to be the same for every side in this triangle. Every side here would have to be 3 times as big as its corresponding side in the other triangle. In other words, they have to have the same ratio. When you take one piece over the other, the ratios have to be the same. If two figures are similar, then you can write what's called a similarity statement. It's just like a congruent statement. Remember when we wrote congruent statements for triangles, we would write triangle, whatever, whatever, whatever is congruent to triangle, whatever, whatever, whatever. Well, now with similarity, you write them exactly the same. The only difference is you do not include that equal sign under the congruent symbol. So we just write, it says that the triangle is similar to this triangle. Make sure your corresponding parts match up just like they did when we did congruent symbols. There are 3 examples that we are going to cover. The first one, example 1, is looking at two figures and deciding whether or not they are similar. If they are similar, then their ratios, as I just stated, would be the same. Find their corresponding parts and write the ratios and see if they reduce down to the same thing. Our corresponding parts in this case, CA, would correspond to EF, so we'd put 38 over 57. Then our other corresponding sides would be 26 over 39 and 20 over 30. So we'd look at all 3 of those fractions, and if all 3 of them reduce down to the same ratio, then the triangles are similar. The scale factor is 2/3 because when I reduce all of those down, it's 2/3 equals 2/3 equals 2/3. So since they are all the same, the triangles are similar, so we can write a similarity statement for our triangles. Notice that I made the corresponding parts match up still. That's also how you would find the scale factor, is you would put one over the other and reduce it down. So the scale factor is 2/3 when it's in reduced form. Another kind of example that you might see is that you are given that the triangles are similar, but that some of the pieces are missing. So what you need to do is, again, find your matching parts, your corresponding parts. Okay? In this case, 20 over 32 would be a pair of corresponding parts. If I reduce down 20 over 32, I get 5/8. So I know that my scale factor from the small one to the big one is 5/8. That would also be the same if I took 25 over 40, because that is also a pair of corresponding parts that we know both values to. So I could reduce that down. I would still get 5/8. To find the value of x, I could take either pair that I know both values to, so either 20 over 32 or 25 over 40, and then I would set the other fraction on the other side of the equal sign to create a proportion. So 20 over 32, that ratio would have to be the same as the ratio of x over 24. I know that because they're similar. It was given to me that they were similar, so I know that the ratios have to be the same. And from there, I cross multiply. Take 20 times 24 and x times 32. When I divide that by 32, I get 15. You can check by using 25 over 40 as a ratio and setting up the exact same thing, and then take 25 times 24, divide it by 40, and you should still get 15. So the missing value here would be 15. The third type of example that you might see is you are trying to create a similar figure. So for example, if you want to enlarge a 3x5 picture into a poster size, for example, so that the longer side is 2 feet long, but you want to know what would the shorter side have to be after the enlargement. You set up a proportion and cross multiply to solve, just like we did in section 1 and just like we did in example 2. So 3 over 5 is what I'm starting with, and I want to figure out what that's going to be after the enlargement. Since the 5 is the longer side, I know that's the one that's going to be 2 feet long. So I do 3 over 5 equals x over 2, because 2 feet is where I'm trying to go. That is fine. Your answer after you cross multiply and divide would be 1.2, and that answer would be in feet. It would be 1.2 feet would be the correct answer up here. If you wanted to keep it all in inches, since 3 and 5 are in inches, you would simply switch your 2 feet into inches. So 3 over 5 would equal x over 24, because 24 inches is what 2 feet is. When you cross multiply and solve that, you get 14.4. This would be your answer in inches. And 1.2 feet is equivalent to 14.4 inches. You might need to pay attention to problems, and when it asks you to find an answer, does it ask you to find your answer in a specific unit? Does it ask you to find the answer in feet or in inches, or does it give you an option? That concludes this lesson on similar figures. The homework for each class is as follows.